Let's now consider some properties of the cross product. So if I have some scalar constant c, and I have two vectors u and v in 3 dimensions, then I can show that u cross c times v is equal to c times u cross the vector v, which is also equal to c times u cross v. Right? And also, I can show that the cross product is actually also distributive over vector addition. So if I have 3 vectors u, v, and w, if I have these 3 vectors, then I can show that u cross the sum of 2 vectors v and w is also equal to u cross v plus u cross w. Right, so as you can see from this follows the distributive property, right? The cross product is distributive over vector addition. Similarly, we can also have u plus v cross w to be equal to u cross w plus v cross w. Right? So we can see that clearly the cross product is distributive over vector addition. And just a reminder from the previous video, we also showed that the cross product of 2 vectors v cross w is also equal to minus w cross v. Right? From this we can clearly see that this is not commutative. Cross products are not commutative. And finally, cross products of vectors are also not associative. So if I have u cross v cross w, this is not equal to u cross v cross w, right? In this case, the grouping matters, right? The grouping matters. So this is not associative. So we can see that the cross product is not commutative, it is not associative, but however, it is distributive over vector addition. Now, let's say we have 2 vectors u and v again. Let's say I have some vector u in this direction and another vector v in this direction, and I have some angle between these 2 vectors, some angle theta. Then in this case, I can actually find the magnitude of u cross v, and this is given by the following equation. So this is equal to the magnitude of u times the magnitude of v times the sine of theta, right? This equation gives us the magnitude of the vector, which is the cross product of u and v, right? So this gives us the length of the vector u cross v, which will be in this direction. So for example, let's take a look at a problem. Let's say we have 2 vectors v and w, and let's say that the components of v is 3i minus 2j minus 5k, and for w we have I plus 4j minus 4k, right? So if I find the cross product of these 2 vectors, if I find v cross w, this is equal to the following determinant with these entries I, j, k. The second row will have the components of v, so we have 3 minus 2 minus 5, and then we have 1, 4, minus 4. So without showing explicit details, this should be equal to 28i plus 7j plus 14k. So if I evaluate this determinant, I will get this vector, which is v cross w. Now, since the vectors v and w are given to us, and since we have found v cross w, we can just use this equation to find the angle between these two vectors v and w, right? We can use this equation to find the angle theta between these two vectors. So if I rearrange this and solve for sine of theta, I will have the magnitude of v cross w divided by the magnitude of v times the magnitude of w, right? So this is equal to the square root of, so our vector v cross w is given here. We have 28 squared plus 7 squared plus 14 squared, and this is divided by the magnitudes of v and w. We have the square root of 3 squared, right? So if I take a look at these vectors, I have 3 squared plus minus 2 squared plus minus 5 squared times 1 squared plus 4 squared plus minus 4 squared, right? And this will give me sine theta to be equal to 7 root 21 divided by root 38 times root 33. And if I consider sine inverse of this entire thing over here, then this will approximately give me 64.9 degrees. So this is the angle between the vectors v and w, right? Now obviously this is not the only way that we can find the angle between these two vectors. We can also consider the dot product of these two vectors, which is equal to magnitude of v times the magnitude of w times the cosine of theta. Using this, we can also find the angle between these two vectors. Now, let's try and determine the cross products of I and j, j and k, k and I. Right? Now, we already know the components of these basis vectors I, j, and k. For I, this is just equal to 1, 0, 0. J has the components 0, 1, 0. And k has the components 0, 0, 1. So we can just use the determinant to find these cross products, right? But instead of doing so, we can also apply some geometric intuition to find these cross products. So if I consider my Cartesian coordinate system again, so let's say this is my x-axis, y, and z-axis. We know that my basis vectors I, j, and k, these basis vectors are just unit vectors that point along the coordinate axes x, y, and z respectively, right? So in the direction of x, we have my basis vector I. In the direction of y, we have j. In the direction of z, we have k, right? And we know that all of these vectors, all these basis vectors are actually orthogonal to each other, right? Since these are non-zero vectors, as they have a magnitude of a single unit, they have a magnitude of 1 unit, they are perpendicular to each other, right? These basis vectors are perpendicular to each other. They're at 90 degrees, or we can say that they're 90 degrees to each other, or we can say that they are at pi by 2 radians to each other. To find these cross products, what I can first do is find the magnitudes of these cross products. So I cross j will be given as the magnitude of I times the magnitude of j times sine of theta, right? We know that these are unit vectors, so this will be just equal to 1 times sine of 90 degrees, or pi by 2, right? The angle between these vectors are 90 degrees. And this itself is just equal to 1. So I cross j, the magnitude of I cross j is just equal to 1. Similarly, if I do the same for j cross k, as well as the magnitude of k cross I will find that these are all equal to 1. All these cross products, all these vectors are equal to 1. They have a magnitude of 1 unit, right? So now that we know the length of these vectors, what is the direction of these vectors? What is the direction of I cross j? So in order to determine these directions, I can apply the right-hand rule once more. So if I consider my vectors I and j, so this is I and this is j, I know that my vector I cross j will be perpendicular and orthogonal to I and j, right? So this vector can either point in this direction, which is in the direction of k, or in the negative direction minus k, right? So what I can do is I can just apply the right hand rule to determine which of these directions it is going to be. So if I point my index finger in this direction and my middle finger in this direction using my right hand, I will find that my thumb will be pointing in the upward direction, right? So the vector I cross j is actually going to be in this direction. So I cross j is actually equal to k, right, in the positive k direction. Similarly, if I use the right hand rule, I can also find that j cross k will give me I, and k cross I will give me j. I can determine all of this by using my right hand rule, right? And there is also an easy way to just remember this. I can just consider the following diagram where I have I, then j, and then k, right? If I go in this clockwise direction, then I can see that I cross j will give me k, j cross k will give me I, and then k cross I will give me j, right? If I instead consider the opposite direction, the anti-clockwise direction, then the cross product of j with I, so j cross I, will give me minus k. If I consider the cross product of I with k, this will give me minus j. And if I consider the cross product of k with j, this will give me minus I, right? And I can also determine each of these with the right hand rule. Now, if I have two vectors, let's say I have two vectors u and v, if both of these vectors are parallel to each other, and let's say they're also in the same direction. So if I have a vector u and another vector v, and they are parallel to each other, and they are both in the same direction, then the angle between these two vectors is equal to 0 degrees, right? So in this case, u cross v will be equal to 0. If they are parallel to each other, then their cross product will be equal to 0. And you can see this from this equation here, right? Sine of 0 degrees is just equal to 0, right? So this becomes 0. And similarly, if my two vectors are parallel but they're in opposite directions to each other, then in this case theta is equal to 180 degrees, and sine of 180 degrees is also equal to 0. So once again, our cross product of these two vectors is equal to 0. So if I consider a vector and I consider the cross product of this vector with itself, then obviously these two vectors are the same, they're in the same direction, they're also parallel, so this will also be equal to 0. Now let's say that we have some vector v, this is some vector v, and we have another vector that is starting from the tail of this vector in this direction, and let's say this is the vector w. Now if I translate this vector v from the tail end of the vector w to the front of the vector w, so that I have a vector here which is also v, and if I do the same thing for the vector w, if I translate it in this direction so that I have a vector like this which is also w, right, then these two vectors have now formed a parallelogram, right? We formed a parallelogram. Then if I consider the magnitude of the cross product v with w, then this is just equal to the area of this parallelogram. This is equal to the area of the parallelogram with the sides v and w, right? So as you can see, the sides of this parallelogram are given by these vectors v and w, and I can find the area of this parallelogram by determining the magnitude of this cross product, right? So let's take a look at an example. let's say that I have 4 points. This is the point A, I have a point B, I have another point C, and the point D. And if I join these points together, this will create a parallelogram. Right? This is a parallelogram. And if I consider the vector A, B, right? The vector from A to B. Let's say this is the vector U that is in this direction. Then since this is a parallelogram, both of these sides are the same length and they're in the same direction. So this vector D to C is also equal to U, right? And similarly, the vector AD, let's say this vector AD is equal to V, and similarly the vector BC will also be equal to V, right? Now let's say that the point A has the coordinates 0, 1, 3, the point B has the coordinates 1, 3, 5, the point C has the coordinates 5, 7, 5, and the point D has the coordinates 4, 5, 3, right? So what I can do is I can find the vectors U and V first. So U is equal to AB, which is also equal to the vector B minus A, right? The vector V is equal to AD, and this is also equal to the vector D minus A. What is B minus A? Well, all that I have to do is subtract the coordinates of A from B, right? So my I component will be 1 minus 0, which is just 1I. My J component will be 3 minus 1, which is 2J. And my K component will be just 5 minus 3, which is just 2K, right? And for the vector V, I am subtracting the coordinates A from D to find the vector AD, right? So I will have 4 minus 0, which is just equal to 4I, 5 minus 1, which is also equal to 4J, then we have 3 minus 3, which is 0K, right? So if I were to find the area of this parallelogram, if I wanted to find the area, this will be just equal to the magnitude of the cross product of U and V, right? Since the vectors U and V correspond to the sides of this parallelogram, then the magnitude of this cross product will be equal to the area, right? And we can find this magnitude by the following determinant, where we have I, J, K in the first row. Second row will have the components of U, which we have determined already, which is 1, 2, and 2. And then the third row will have the components of V, which we have determined here, which is 4, 4, and 0, right? And if I evaluate this determinant, I have I times 2 times 0 minus 8, so we have minus 8, minus J times 1 times 0 minus 4 times 2, which also gives me minus 8. Then I have plus K. So we have 4 minus 8, and this is just equal to minus 8I plus 8J minus 4K. So what did we do here? We just found the cross product of U and V. Now to find the area, we have to find the magnitude of U cross V, right? So the magnitude will be the square root of minus 8 squared plus 8 squared plus minus 4 squared. And this is equal to the square root of 144, and this is equal to 12. So the area of this parallelogram is 12 square units.